Okay, Silicani, so you are doing functions. That is, in some ways, we're doing straight line functions at the moment, but we are going to be moving to like exponential, hyperbola, parabola after this unit. And what I'm going to do, Silicani, is I'm actually going to also put in previous years, we obviously done stuff for functions. And what I can do is I can put some of those previous years recordings in the Google Classroom so that if you have maybe like you're doing parabolas or exponential graphs at the moment and you need a bit of extra help, then you can just go straight to our Google Classroom and see those lessons before we even do them this year. You can have a look at those if you're struggling with anything. Or you just want to learn a bit more. Okay. And you, Stephen, what are you currently doing at your school? What are you currently doing? So the question is, as you come to class today, what are you currently doing at school with your teacher? It's helpful for me to know because I also know what stuff to put in Google Classroom to assist you guys. Okay, cool. All right, well, let's get started for today. So just in terms of the normal stuff, you can see all our best practice stuff up here. But also this last week, we started what were called exam boot camps. And so session 1 is already done. But if you would like to join those, you are allowed to join for the final 2 sessions. And then there is a reduced price of $2.99. If you would like to be part of that, you can just speak to our customer helpline and we will assist you in getting started. But yeah, let's get started with the lesson for tonight. So step 1 in tonight's lesson, I just want to give a shout out to these students. So a big clap because they have completed the quizzes. And the quizzes are an important part of our learning. And so please make sure that you are completing the quizzes each week. And if you haven't completed certain quizzes, go back and do them because they will help you revise for exams. So just a shout out to those students. Okay. And then for today's actual lesson, let's start with a bit of a warm-up just to get things moving. What is the equation of the line that you see on the screen there? Is it A, B, C, or D? We're going to start with just making sure we absolutely perfect with straight lines. So put your answer in the chat. Do you think it's A, B, C, or D? Okay, so again, once you have got an answer, put your answer in the chat. We are trying to figure out what the equation of this line over here is. Now, a key thing in all straight lines is what we call the standard form of straight lines. And the m is the gradient, or how steep the line is, and the c is the y-intercept. And I can actually see that the y-intercept here must be 3. So what is the correct answer going to be for this one? A, B, C, or D? So to work out the gradient, let's have a look. Let's choose 2 points on the line. And if I go between those 2 points, I have to go across by 1 and up by 2, or sometimes we count it like that. And so we would say the gradient is 2 over 1, and therefore the equation of this graph is going to be y equals 2x plus 3. Is there an option that looks like that? Yes, there is. It's going to be C. So C would be the correct answer. Okay, well, let's do another one like that before we really get moving for today. Find the equation of the line passing through the points 5, 11. So it's going through 5, 11, and it's going through the point 9, 3. And one of these options, A, B, C, or D, is going to be correct. I want you to tell me by putting your answer in the chat. Just give me a thumbs up if you can hear me okay. I'm not sure if my internet signal is a bit low. So just give me a thumbs up if you're hearing me clearly and you know what to do. Okay, fantastic. I see Amelia's hand. Anybody else hear me loud and clear? Silakaria, I see that hand. Sange, Musaleni, Stephen, how are you hearing me okay? Is the signal good? Zalinda? I think maybe Sange was having some joining issues there. Fantastic, Stephen. Awesome. Okay. So, Zalinda, perfect. Okay. So, if we look at step 1 for this, you're going to need to find the gradient, and then you're going to need to find the y-intercept. So, I'll give you some more time, but I want to see those answers coming in. It's a team sport. We are learning together. I want to feel the team vibes. So we have, for the gradient, I'm getting 8 over minus 4, which is minus 2. So it can't be A and it can't be B, but it could be one of C or D. And there's 2 ways you can do this, and I don't mind which ways you do it, but for now, I'm going to use the substitution way where I just take the point 5, 11 and pop it in there. So 11 minus 2 times 5 plus C. And then if you've got 11 equals minus 10 plus C, and you bring it across, so you should then get minus 2x plus 21, which is D. All right. So that is still our bread and butter straight line stuff. Give me a score out of 10. How are you feeling about straight lines so far? Where 10 is like perfect understanding, 0 is very little, and 5 is like sort of, but not that confident. How are you feeling about straight lines so far? Because then I know if I can see you're very confident, I'll turn up the heat, but I don't want to turn up the heat before everyone is ready. Okay, next question. Which of the following sketches could represent 4x minus 5y equals 20? This is a little bit harder, so I'm turning up the heat. Maybe someone could give us a tip in the chat. What should we do first to get ourselves rolling? Standard form. I totally agree, Sange. I think that's a hugely helpful hint. And then after you put in standard form, I want to see what option you think is correct. A, B, C, or D. So I'm going to go with Sange's suggestion and start putting it in standard form. Or if I like, I could write it like this. Most of us are more used to seeing it like that. Which one do you think is the correct answer? Well, the gradient is a fraction, but it's still positive. So what do we know about positive gradients? It has to be either, basically, the only ones that have positive gradients are A or B. But now, of these two, which one is it going to be? So Amelia has made a call. Who else agrees or disagrees? I want to see people commit. You can't sit on the sidelines. You need to put yourself in the game here. So my attention is drawn to the y-intercept, and the y-intercept is negative. And because the y-intercept is negative, it cannot be this one because the y-intercept is positive. So the correct answer has to be B. And according to like the algebra we did, that would be a -4 over there, the y-intercept. Okay. All right. I want to see you find me the equation of the line going through these 2 points. And then you can tell me which of the 4 options. And since you guys are very confident with straight lines now, or at least it looks like you are, it shouldn't take too long. This has just got a few fractions, which can make it a bit more exciting. But I'll give you a minute to do that one. Okay, how do we get the equation of these 2? Well, m is going to be -8 minus -5. And this is going to be 5 minus -3. So that's going to be -3 over 8. So we know we have, and let me do the other method this time. So we are going to use the point 5 minus 8. And using that second method, we go y minus -8 is equal to the gradient, which is -3 over 8. And then x minus 5. And then we would have y plus 8. And then this would be plus 15 over 8. But I'd still have to move this 8 to the other side. So which option do we think is correct? Well, we know that actually 8 can be written as 64 over 8. So we could just go 64 over 8. And then it was, oh, but it's a minus that, sorry. And then it's plus 15 over 8. So that's the y term. And then the minus 3 over 8x. And that means that I should end up with minus 49 over 8. Which, if I look at the answers, the answer should be C. Okay, well, everyone, I think it's time for me to take it up a notch. So let us go to what we call parallel lines. Now, if I look at this, these two lines, they are parallel. And lines that are parallel will often have these little arrows on, or we can see that they're equidistant from each other. But the other bit that's important is parallel lines will always have the same gradient. So you can see here that the gradient of both these lines are 2. Now, what I'm going to do is I'm going to make you a new question. I'm going to give you another line, which is parallel to these two. So let's say I put it over here, and I'm going to give it the gradient of 2. And if I give it the gradient of 2, it's going to mean that it's parallel to these. So notice how I just go 1 across and 2 up. That's how I can make it parallel. Now, I'm going to give you a point on the line. So this point over here is the point 7 minus 3. I want you to work out the equation of the blue line. So off you go. You've got these 3 lines. They're all parallel to each other. Parallel lines have the same gradient. Can you work out the equation of the blue line? Oh, sorry. And where should I start first? So if you're feeling generous, put a tip in the chat for the rest of your classmates. Where would you start this question? I would start with the gradient, because I know that because it's parallel, the gradient must be the same. And you can visually see this even. Like if you look at this, you go 1 across, 2 up. On this one, you would go 1 across, 2 up, just down the line. 1 across, 2 up. So you know the gradients are the same, but now I need to know, what is the C value? Who can work out the C value for me? And pop it in the chat. So I'm putting the point 7 minus 3 in there. Now I still need to do some subbing in. What is my C value going to be? Well, it looks to me like C is minus 17. And so the equation of my blue line is 2x minus 17. And that kind of makes sense when you think about where it's going. Hey, you can see how much further down it's kind of going. So to me, that makes a lot of sense. Okay, so this is something which we're going to get used to today, is we're going to use parallel lines and their relationships to help us kind of explore different types of questions. So nice, easy multiple choice question. A line parallel to y equals 3x plus 4 would have what type of gradient? A, B, C, or D? This is an easy one. Put your fingers to the test. So the gradient of this line is 3. If another line is parallel to it, the gradient must also be 3. Okay, so it's not C, because C is not the gradient. That's the whole linear term. So it must be it must be this one over here. It's going to be A is the correct answer. Okay, watch out for that. All right, now, different type of question now. Determine whether or not the following two lines are parallel. Hold on. How am I going to tell there's no drawing to help me? So what am I going to do if there's no drawing to help me? How am I going to know if these two lines are parallel? Well, let's have a vote. Say yes if you think they're parallel. Say no if you think they're not parallel. So yes or no vote. Do you think these two lines are parallel? We'll call them the red line. So we'll call this one the red line. And we'll call this one the blue line. Are these two lines parallel? Yes or no? Ooh, I think people know things. So let's have a look. I don't know what the answer is, but what I know is I need to put this in standard form first. And let's use the colors that I chose. So if I write this, I get minus 2x plus 1. And if I write this, I get minus 2x plus 3. And the most important thing is that these are the same. So therefore, they are parallel. And the reason they're parallel is the gradients are equal. Okay, fantastic. I want to know, a line has an equation, 3x plus 5y equals 7. What is the gradient of that line? What is the gradient of that line? What do you think it is? A, B, C, or D? What gradient do you think it is? A, B, C, or D? So pop your number in the chat. So this feels like putting it in the standard form would be a good idea again. Okay, so we have, if we move it across, we're going to get, and remember the 5 has to divide both, but the really important bit, is there a minus 3 over 5? Yes, there is. So that is going to be B is the answer. Yes. All right. Well, you guys do seem to know your straight line stuff. So I'm going to give you a different type of question. So I'm going to give you two straight lines like this. Let me move them actually. I'll move it down to below this. So I'm going to give you two straight lines, and you need to find where those two straight lines cut each other or intersect. Now, I don't even know what it looks like, but let's just say we have a red line, which looks like this. Oh, that doesn't look like red, does it? Let's go back for a second. Oh. So let's say I have a red line that looks like this, and then I have a green line that looks say like that. And I want to find the place where they cut each other. Does anybody know how we would do that? What do I need to do to find the point of intersection? Now, I haven't covered this yet, but I feel like I can throw it in because some of you might have seen it in functions or even in grade 10. How do we find where two straight lines cut each other? You can put your hand up if you like and just tell me audibly. Siamtanda says equate the formulas. Yep. Equate is the one way you could do it. Some people might say substitution. You sub one equation into the other. And so my suggestion is you take the easier looking one. So this one looks easier, let's say the blue one, and you sub it into the harder looking one. So what I want you to do for me is I want you to find me where these 2 points meet each other, and all you're going to do is you are going to sub this minus 2x plus 5 in here, and then I want you to solve for x for me, and then after you get x, I want you to solve for y for me. Okay, over to you guys. Find me the place where these two straight lines meet, or what we call the point of intersection. Ooh, excuse me. What x value do you get? What value are you getting for x, and what value are you getting for y? So this is another common, very common question in this section. So I've got minus x plus 10 is 7. Then I could have minus x equals 7 minus 10. So minus x is minus 3, which then if I divide both sides by minus 1, I should get x is 3. What is my y value going to be? So I've got the 1 coordinates. I know that the x coordinate of the point of intersection is 3, but I still need to find the y value. How am I going to find that? And what's it going to be? So we sub the x into the easy equation. Yes. So let's look. So we have a minus 2, and where there's an x, we're going to leave a space. And then minus 2 times 3 is minus 6 plus 5. So that's minus 1. And so the point of intersection, and literally it's a point where the two lines cut each other, is going to be the point 3 minus 1. And that's it. Give me a score out of 10 about how you feel about points of intersection. So 10 would be like you feel very confident. 0 would be no confidence. 5, some confidence. I just want to know, it's an important skill for this section. I'm not going to do a million of them if you understand it, but I just want to check. Okay. So it looks like we should probably do another one not too far from now based on the scores. Like we have some confidence, but we need a bit of extra practice. Keep your votes coming. Give me a score out of 10 about how you feel with points of intersection. So Tsepang, you are absolutely correct. Points of intersection are simultaneous equations. I need to actually emphasize this. So Tsepang said, so isn't that simultaneous equations? And yes, if you are trying to find the point of intersection of two equations, two straight lines, we use the methods of simultaneous equations to help us. And so that's why we just sub the one into the other. It's exactly that section that we learned earlier in the year. All right, now we've done the first half of the lesson. What I want is I want everyone to turn their cameras on, and I want you to stand up with me. And we're just going to do a quick speed break. We're going to take some breaths. We're going to shake around a little bit, and then we're going to do some exercise to unwind. But let's start with some breathing. So we'll start with this. Breathe in. Breathe out. Breathe in. Okay. Then I want you to shake out your arm, get nice and loose. So any tension or stress in your body, you just want to get it loose. Because if you're feeling stressed or if you're feeling tense, your brain's not gonna relax and allow you to learn. Shake out your legs. Shake them out nice and loose. And then what we can do is just roll your shoulders back nice and loosely. And then roll them forward after that. Okay, give your hands another shake, give your arms a shake. You want to feel floppy, like loose and floppy. Give your legs another shake. Get the blood flow to move through your body. And then just to get the heart rate up, we're going to do jumping jacks. This is a jumping jack. We're going to do 10 of them. Make sure that the space around you is clear, that you don't whack somebody or something by mistake. And we'll start in 3, 2, 1. Let's go. 2, 3, 6, 7, 8, 9, 10. And that is that. And I've got a nice little puzzle for you for tonight, just to let your brains have a moment. So you often see these things on the internet. Can you tell me how much a red square is worth based on what you can see here? So, I mean, yeah, I agree with you. The green circle is a 5. So let's put that in. What is the yellow square worth? So the yellow square is going to be 2. Yes, Mtanda, you are quite correct. It's going to be 2. So now the final mystery is, what is the red square, or not square, red triangle going to be? What's that going to be worth? So we have 10 minus something times 5 equals 5. So what needs to go into that triangle? Well, the only way this can work, and Sapang, I agree with you, is that this has to be a 1. Because then 10 minus 1 times 5, 10 minus 5 is indeed 5. If I had another number here, it would never give me 5. And so the correct answer is indeed 1. Very, very nice. Okay, so I hope you enjoyed our little break. Give me a score out of 10 about your concentration. So is your concentration at 0? Is it at 10? Is it at 5? Let me know in the chat so I know kind of how to pace the next part of the lesson. So you are, okay. Give me a vote on your concentration. Okay, so we are definitely feeling a bit tired. So let's just focus on some simple things just to get us through to the end of today. All right, you need to write down the equation of the line that is parallel to this, but passes through this point. And since we're all feeling a bit tired, we're going to help each other out. So where are we going to start as we try to figure out the equation of the line in this question? We know all straight lines have this format. What should we start with? Amelia's at -7 on the concentrations things. Siamtanda, I agree with you. The gradient is a great place to start. And what is the gradient going to be? Because they give us, yeah, we can borrow it from this one, because really, if it's parallel to y equals 6x plus 1, it must really just be 6. But now we need to find what c is. What is c going to be? I mean, it's a Monday is a tough day for maths, but the good news about getting stuck in today is that it still helps. Even if you feel tired, it's like, it does make a difference over time. So one of the things you might have realized is that 0.8 is actually already the y-intercept. You can sub it in to find c, but you'll notice that anything times 0 is nothing. And so you get 6x plus 8. And that is the equation of the line that is parallel to this line, but goes through the point 0.8. Now, that would be an easy version of the question. A harder version of the same question would look like this. Determine the equation of the line that passes through the point 1 minus 5, but is parallel to this line. And I want to let you do this by yourself. So I'll give you 2 minutes. If you have a question, raise your hand or make a comment, but use the idea that we just showed in the previous question to help you do this one. I feel a bit stuck with the green bit. What should I do with the green bit? I feel like the information is not very accessible, but if I was to do that, then information becomes a lot more accessible. So what is the equation of the line that goes through 1 minus 5, but parallel to this? Yep, so Connie, you and me were thinking the same thing. So what is the c value that I get for this straight line? What do we get for the c value? So the equation of this line is going to be minus 2x minus 3. So if I was visualizing the straight line, to draw it, it would go through minus 3 on the y-axis, and it would have a gradient that goes up like that. Okay, so it looks like parallel lines are actually not that difficult. We just sort of apply the idea that if lines are parallel, the gradients are the same. But what we're going to finish with today is the relationship between lines that are not parallel, what are the relationship, or what is the relationship between this green line here and this yellow line here? Are they parallel? No. What is their relationship? What's the nature of the relationship between those two parallel, those not, they're not parallel, but, oh, did I make a mistake in the previous? I'm looking at your thing there. Let's have a look. So -5 minus 2, -5 plus 2. No, that's correct. Yeah, yeah. So the -5 goes where the y is, and the 1 goes there. I get -2, becomes +2, definitely -3. So I'm happy with that one there. Yep, these lines are perpendicular, or they're at 90 degrees to each other. Another one could be this over here. And what I want to do is just a little bit of an investigation quickly. So I want you to find me the gradient of AB, and I want you to find me the gradient of DC. Now, that's just focusing on these ones over here. We know that D is the point -1, 3, and C is the point -4, -3. We can see it here and here. And then I'll help you out for the top one here. You've got the point -5, 2, which is A. And you've got the point B is 1, -1. I want you to work out the gradient of the green line. And I want you to work out the gradient of the yellow line. And see what you get. What do you get for the gradients of those two lines? Oh, I made a mistake. I think I'm also getting a bit tired. -1 minus 2, and then 1 minus -5, which gives me -3/6. Or I could also say -1/2. What is the gradient of DC? What is the gradient of the yellow line? I'm guessing it must be positive, because if I look at the angle, this looks like sort of quite a flat one, the green one, and it looks negative. What is the yellow one's gradient going to be? So that's interesting. They're definitely not the same. And the gradient of AB is -1/2. And the gradient of DC is 2. Okay. Now there's some resemblance, but it's not perfect. So I just want to check something else. Find me the gradient of GH and find me the gradient of EF. So gradient EF and gradient GH. And we're going to see if we notice anything. So I'll make this one, this is the blue one, and then this is the pink one. I want you to work out the gradient of those two, and I want to see if we notice anything about the relationship between perpendicular lines. So just say, when you found the gradient of EF and GH, just say done in the chat, so I know that you are done. then what about GH? So that would be 4 minus 4. Oh, I'm doing the 4 minus 0 over 4 minus 2, which is 4 over 2, which is 2. Interesting. So what I notice, and I don't know if you notice this too, is that the pink one and the yellow one have the same gradient. And now that I look at them, these two are parallel. So that we learned about that before. That's great. But if I look at the relationship between perpendicular lines, they are not the same. But what type of relationship do they have? Well, what we say is that they are negative reciprocals of each other. So what that means is that if I take the one gradient and I flip it over and I change the sign, I will get the other one. So just to show you how that works, if you've got minus 1 over 2, if you flip it over, you get minus 2 over 1. But if you change the sign, it becomes plus 2 over 1. So that's lines that are perpendicular have negative reciprocal gradients. Some teachers will say that lines that are are perpendicular to each other multiply to give you minus 1. So let's see how that works. If I multiply minus a half times 2 over 1, well, I'm going to get 2 over minus 2, which is minus 1. So another way to recognize perpendicular lines is if you multiply the two gradients together, they get minus 1. Or the way that I think about it is, if I've got the 1, I just flip it over and change the sign to get the other one. Give me a thumbs up if you understand the relationship between perpendicular lines and their gradients. Give me a thumbs down if you don't understand it. I just want to make sure you understand the relationship between gradients and perpendicular lines. Okay. Tapan, I see that hand. Who else has a thumb for me? Up or down? Or in the middle? Let the people express their views. Okay. Last 2 questions for tonight. Write down the equation of a line. Actually, let's do that. Let's leave that one out. Write down the equation of the line that is perpendicular to y equals a half x plus 3. So write down the equation of the line that is perpendicular to this, but goes through the point 0 minus 1. This is going to be our last question for today. Last question of the day. So do your best to get the answer and then pop it in the chat. What do you get? What should I even be looking at? So we know that we need to find the equation of a line that looks like this, but the gradient of the perpendicular line is not going to be a half. It's going to be minus 2 over 1. So the line that we are looking for, it has a gradient of that, but it goes through the point 0 minus 1. So then this has to go into this. Oh, but we can see that's already the y-intercept. So C would be minus 1. And the equation of the line I'm looking for is going to be minus 2x minus 1. All right, everyone. So just to go over what we did tonight, we looked at straight lines again. We looked at how we can change straight lines from non-standard form to standard form. we looked at the relationship between parallel lines, we looked at the relationship between perpendicular lines, and how we can use that information to find the equations of lines. Now, in the next lesson, what we're going to look at is we're going to look at more difficult perpendicular lines questions. So some stuff like that. And we're also going to talk about what's called the angle of inclination. Now, if we have a, say, straight line like, let's say like that, the angle that the line makes with the positive x-axis is called the angle of inclination. And we can use trigonometry to help us figure out what the size of that angle is using the formula m equals tan theta. So that will be a lot of what we will do in the next lesson. It will be perpendicular lines and the angle of inclination. Okay. That is it for today, everyone. I hope that you got some